All right, so check this out. We're looking at Google Earth. Here, my friends, is the Earth. The Earth that doesn't move because the computer's frozen. Come on, computer. Come on, computer. It's going. It's thinking about going. There we go. This is why I wanted to do it on the big computer, because the big computer was supposedly faster. And yet it's not. All right, here we go. This, my friends, is the Earth, and it spins around. La-di-da, ti-da-di-da. All right, now, let's go over to a few places. Here's Hawaii. There it is, right there. Hawaii. All right, cool. I'm going to go over to this thing right here, the Mid-Atlantic Ridge, and we're going to take a look at this thing. Can you actually see the plate? Right here. You can see the plates. In fact, I don't even need to put in the plate boundary, but I can. There it is. But you can actually see it, because if we look at the topography map, and the topography is just showing off the ocean depth like this. Right here, you can actually see the plates. All right, the average depth of this mid-ocean ridge is about 2,500 meters. It's pretty deep. Also notice that there's like these lines that kind of go perpendicular to the ridge. It almost looks like a scar, or like, you know, like. All right, so when I got married, I was like 120 pounds and fighting in a eskrima tournament. It's like Filipino martial arts. And then I got married and I got fat. I got like gained lots of weight really quickly. It's just because I ate a whole bunch of food, and back when I was in college, I was basically starving. So what I had, well, my wife got preggers, and then I ended up like eating all the food that she didn't eat. So what I ended up having was I got these little stretch marks, and you can ask your parents about the stretch marks, and it's not an embarrassing thing. It's just, you get them. So what's happening is the Earth is kind of pulling apart, and it's kind of creating these little scars. And these scars are called fracture zones or transform faults. They look like little slashes or cuts that run perpendicular to the actual plate, which is going vertical. Does that make you sensey? We cool? All right. And then here's the thing that we can look at. And this is the 4 different types of maps that I'm showing you. And I think this is really cool. If we look at the seafloor age, I think that would be the next good map to look at. If we look at the seafloor age, look at this red. So here's the legend here, folks, is the red is the youngest part of the ocean, and the blue is the older part of the ocean, and it kind of goes into the rainbow in between. So the green is about middle-age ocean, and then this is like baby teenager ocean, and then this is like old fut ocean out in the side. Cool? Now, the red ocean in the middle is basically the newer ocean. And what's happening there? Well, that is a sign of this thing is what? Is it converging? Are these two plates right here converging, diverging, or transforming? The world is breaking apart. And when it breaks apart, what do you mean by breaking it apart? It's diverging. It's pulling apart. And the reason why you can kind of tell is because right at that boundary, there's this patch of red. That means it's new over here and it's new over here. That means it's pulling apart, and there's new ocean crust that is forming underneath that. And that makes sense. That's why there's new ocean in the middle, because this thing is pulling apart. These boundaries are diverging. We cool, Leos, with that? Now, let's take a look a little bit more. And here's another tall tale giveaway that this thing is diverging. Take a look at where the volcanoes are. And you guys already did the not the volcanoes, but take a look at where the earthquakes are. The earthquakes happen right on top of the actual boundary. They're on the line. And this is a kind of a tall tale sign that this is a divergent plate that we're looking at. You can almost tell how these plates are moving based off of the ocean floor or based off of where the earthquakes are. I think that's pretty awesome. All right, now let's say, all right, so I want you to also notice they're not that deep. The orange dots are the depth, and these are about 33 kilometers deep, and they're not very big. These earthquakes that happen along mid-ocean ridges are generally like 6.0 on the Richter scale, which is, I mean, it's big, but I mean, think about it, they're happening like super underwater, so it's not really, you know, affecting us that much. It's not like you're gonna get huge tsunamis up in the, you know, over in New York because of them. Are we cool with that? All right, let's go to the next place and we'll figure out what's happening. Let's go over to the Indian Ocean, folks. Whoa, 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 zoomed in way too far. All right, let's take a look at the topography of this sucker right here. Can you almost see can you almost see the plate? Look at it closely. Over here. You can kind of almost see it. There's actually, it's not as obvious as the other one. So you have a plate coming over here and a plate coming over here. Now, let's look at the seafloor age, and I want you to tell me, are these converging or are they diverging? Just by looking at this sucker. Here's the seafloor age. Are these plates, the Indian plate and the Somalia plate, are they converging or are they diverging? They're diverging because there's newer ocean over here and then there's older ocean out here. Now, here's a challenge for you. Now listen closely, ready? Look at the plates. Look at this picture. Look at this entire map right here. And I want you to tell me, are there two places in the ocean that you can actually see diverging plates as well? It's just they're not as like obviously red. These are called like extinct diverging, extinct spreading centers. This is called a spreading center near Indonesia. Yeah, right here. Look over here. This guy right here. This is an extinct diverging plate. This used to be a plate, and it was diverging, but it's not, you know, spreading anymore. There's another one right here, and this is an extinct diverging plate. They were spreading, but then a long time ago they stopped spreading, and so, you know, now they're just growing older in age. But you can kind of see now, of these two, of this diverging plate over here and of this diverging plate over here, which one's older? Left is older, right is older. What do you think? The one on the left. Why the one on the left? Nicholas, Sophia. Because it's bluer. Yeah, because there's older plates around it. It's kind of the green age as opposed to the yellow age, which is the younger part of the two. So do you guys see how we can actually glean information? We can actually take information from looking at different pieces of data. One teacher will show you, I'm sure that there are teachers out there who say, okay, here's what we're going to do. We're going to do plate boundaries today, and they're going to show you the plates and all that kind of stuff. But I think it's so cool that you can actually say, okay, where's the plates? Where are the earthquakes? And based off of that information, I can figure out what I'm talking about, or how these plates are moving. And this data isn't old data. This is new data. Like these earthquake data comes up from like 5 minutes ago. All right, I'm going to take you over to Alaska. I'm going to turn off the seafloor age. I've got the boundary map up. All right, so check this out. Looking at the topography, without even looking at anything special just yet, you can kind of see where the plate is. This is called a trench right here. Do you see the trench over in Alaska? And notice there's this big chain of islands right here. There's just islands that are on top of here. Now, what would you say these two plates are doing? Do you think that they're converging, diverging, or transforming? I'll give you a hint. Let's take a look at all the earthquakes. The earthquakes, here, let me see. Here's the plate boundary down here. The earthquakes are all happening up on top. So they're converging because all of the earthquakes, almost all of the earthquakes, are pretty much on one side. It's very, very, very shifted over to one side. And if you look at where the volcanoes are, boom, look at all of those volcanoes. No wonder there's all of these islands that are created because there's all these volcanoes out here. And we were talking about how this these two plates converge. This is the Pacific plate, and then up on top, I think this is the North American plate, and they're coming together, and they create all of these volcanoes on one side. And I can show you that because you guys were asking, well, what is the like, let's take a look at this interactive thingy. This is what's going on. We got the oceanic crust, which is coming into the continental crust, and then there's a volcanic mountain chains which will form because when they come together, this friction creates, like, melts this oceanic crust and it creates magma, and then that gets shot up into the continental crust. So based on where those volcanoes are located, you can tell which plate is going under. And Sarah, go and type your question right off the bat, and I can read it and decide how I want to answer that. If I want to answer it now or if I want to wait till I'm done with my lecture. Are we cool with this? I took a look at the earthquakes. I took a look at the volcanoes. Notice how there's a line of volcanoes, and we call this, what do we call this? Let's see. This is like a volcanic arc. That's what they call it. That's right. This is a volcanic arc. Whoa, whoa. I'm going to have to mute somebody. There we go. This is a volcanic arc. I already did. Don't worry about it. That is formed because, like we said, the oceanic crust subducts underneath the continental crust, and here's the subduction zone. Magma is created, volcano mountains, bada bing, bada boom. This whole thing becomes, is a part of the mantle, and blah 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 blah. Are we cool with that? Yes, we can move on. All right, wait. And Sophia, you have a question. Okay, when Pangea comes, what's going to happen? Wait, what was Sophia's question? When Pangea comes around, what's going to happen to the plates? Pangea? Pangea, I didn't teach that to you just yet. And what that is actually, that used to be what the plates look like. All these plates were actually all put together, and they were all kind of like one big landmass, and we call that landmass Pangea. And the Pangea split apart, and these ocean crusts these plates are moving, and that's what we're studying right now. Cool. All right. So we've got a pretty obvious subduction zone right here. Subduction zone is a converging plate where one is going under the other. All right. I'm going to take you over to the Andes mountain range. Now, by looking at where the volcanoes are and looking at where the earthquakes are, okay, here's the plate, the Nazca plate and the South American plate. Looking at where these things are, what are these two plates doing? Are they converging in a subduction kind of type of deal? Or are they diverging? Or are they transforming? Notice it has a very similar trench that's created when we're talking about converging things. All right, and yes, Jenna, you are absolutely right. They're converging because all of the earthquakes are on one side of the all of the earthquakes are on one side of this kind of these two plates. All the volcanoes are also on one side. Now, this thing didn't create, the names of the plates is, this is called the Nazca plate, and this is called the South American plate. And there's small plates within here, so it could get kind of complicated, but basically, these are the two major plates that are colliding with each other. And one is going under the other, and you can see where all of the volcanoes are forming. Now, this doesn't form an island chain. This forms what we commonly call the Andes Mountains, and it's a beautiful mountain range. Let's see. Let's find a nice picture of the Andes Mountains. There we go. Whoa, what is that? I don't even know. That's so cool. Here we go, Andes Mountains. It's that mint that you get after you have a fancy dinner. It's green, it's minty, I really like it. Actually, I think those are called Andes. Yeah, I like those. All right, are we cool with that? Those are the Andes Mountains. Now, let's see, what else should we talk about? All right, if we take a look at the earthquakes over here, all right, here's an interesting thing I want you to check out too. Look at how the earthquakes are moving. All right, get over to the other side of the Andes Mountains. I'm not sure. Jenna, I'm gonna have to answer your question later. Let me think about that one. All right. Anyway, here I want you to take a look at this. Cool. Look at the earthquakes over here. I'm gonna turn off the volcanoes because that's a little confusing. Look at the earthquakes. Let's take a look at the earthquakes. You got you got shallow earthquakes over here, and then there's a lot of deeper earthquakes. Do you guys agree? They're like shallow earthquakes, deeper earthquakes, even deeper earthquakes, and then the deepest kind of earthquakes over here. Like you got the red ones over here. Now look at this one over here. Take a look at over here. This plate right here. These two plates. Look at how those things are not as... I mean, you have the shallow earthquakes, and you have the 35 to 70 kilometers deep, and then you also have a few blue dots, but you don't have the red dots. You notice how the earthquakes over here are deeper than the earthquakes over here. This is a little bit tough thing to think about it, but anyway, let me kind of talk to you about it. I think if I look at this kind of deal right here, this might help me figure it out. Ah, yes it does. Look at this. The plate over here, which one's older? The plate on top or the plate along the South America on the bottom? Which one's older? The South American plate is older. An older plate tends to be denser. It tends to pull things down even more. Whereas a younger plate, like for example, the Cocos plate and the Pacific plate, those are younger plates, and it's lighter, which is why it's more buoyant. It floats better, basically. And so the younger plates float better than the older plates, which don't float as well. Which is why there's not as deep earthquakes up here, and there's very deep earthquakes over here. Because this Nazca plate doesn't float as well, and it goes deeper underneath the South American plate than the Cocos plate, which is younger, so it floats better. So its buoyancy is bigger. Does that make sense? Like, all of a sudden, to me, this became like, wow, that's really cool. Exactly, Jenna. I think this is radical that you can look at these earthquakes, and from this earthquake, you can kind of figure. I can tell you this story, and I'm not making this up. I mean, this is all true, and it makes sense. All right, so we talked about the Andes mountain range. I want to show you this little cute thing of volcanoes over here. There's volcanoes down here. See all those volcanoes? Those are called the Scotian Arc. I think that one's a cute little thing right there. And then you have this plate right here, this Nazca plate I showed you over here. What is he doing? The Nazca plate and the Pacific plate are doing what? Converging, diverging, transforming. What do you think? Jenna says transforming. I will show you the picture. I will show you the seafloor age, and now you can tell me. It's almost obvious. converging. No, they're diverging. They're spreading apart because the newer stuff is in the middle and the older stuff is on the outside. In fact, this Nazca plate, I can almost tell you exactly what's happening. He's diverging away from the Pacific plate, and he is subducting underneath the South American plate. Diverging. Got it? Just by looking at the volcanoes, the seafloor age, the earthquakes, all of that kind of stuff. I just think it's so cool. All right, let's take a look at another place. I'm going to go over to the tallest mountain ranges in the world. My friend's going to be doing mission work over here. It's awesome. We got the Himalaya Mountains right here. In fact, my favorite place in the Himalaya Mountains is Mount Everest. Let's take a look at that one. It's beautiful up there. There we go, zooming into Mount Everest. Whoa, that's pretty zoomed in there. There we go, let's look up a little bit. And there, my friends, is what sitting on top of the world looks like. Actually, I'm sure that it looks much better than what Google Earth can show you. And people spend millions and billions, and they all try to climb the top of Mount Everest. And I hate to say it, but 1 out of every 6 people who try to climb to the top die. Let's see if we can get the nicest picture from the top of the world right here. Let's see what this thing looks like. Show me that picture. Show me that picture. Oh, that's beautiful. Isn't that beautiful? The Himalayan Mountains. You're like... There, I love this picture right here. This is Mount Everest, folks. Alright, anyway. Because of snow leopards? No. Because of lack of oxygen. Basically, they climb up there and they're all exhausted. Alright, how did we get Mount Everest? How did we get this huge... how did we get this huge mountain range over here? What's going on? Here, I'll show you the plates. Okay, wait. Plate boundaries, where's this plate? Alright, this plate looks like there's a plate that kind of goes right through the middle of this thing. So, what can you tell me about these things? Are they... Yes, exactly. Sophia and Vernon, you've got it. The plates are converging. These two plates are pushing together. Now, in this case, one is not going underneath the other. Like when we see oceans going into continents, usually, it's always feel that one goes underneath the other. But in this case, both of them are kind of saying, well, I'm going to be on top. And they both kind of get pushed together so that you create this huge mountain range. And that's what's going on right here. Let me show you let me show you the earthquakes. Look at the earthquakes. The earthquakes, see, when we have converging plates, we usually see earthquakes only on one side of the of these converging plates. But in this particular case, they're dispersed all over the place. They're kind of random, you know what I mean? They're like just all over the place. That's another sign of converging plates within two continents. Two continents colliding, they're not going to be on one side or the other. Here, I'll show you, watch. When we look at the volcanoes don't really help us out here in this case. And obviously the seafloor age, not really helping us out. Because this isn't the ocean floor down here. You see what I mean? But I can kind of tell you from the seafloor age, I can kind of say, well, it must be that this plate is moving away, you know, this Indian plate is moving up and to the right. And it must be colliding with the Amur plate, and those things are creating the Himalayan mountains. We cool with that? All right. So these earthquakes that this thing feels, a lot of this convergent plate is actually causing earthquakes all over the place, and a lot of the ones you feel in China, or they feel in China, is caused by these two plates kind of colliding like that. All right. I told you that the earthquakes don't help. Let's go over to the Western Pacific. Now, tell me, what do you see? You can see the plates. I'll show you that right now. But I'm going to show you the earthquakes. Let's look at the earthquakes. Oh my goodness. Those things are like crazy all over the place. What's going on? Holy wow. All right, let's kind of look at this place right here. Right over at Indonesia. What do you see? What kind of thing is this coming in? They are converging. Yes, exactly. And the specific kind of converging that they're doing is they're subducting. The Australian plate and the Indian plate is subducting underneath the Burma and the Sunda plate. What does subducting mean? Subduction zones. A subduction zone is basically when you have a ocean plate crashing in with a continental plate, and you form a subduction zone. At the subduction zone, a dense oceanic crust slips under the continental crust and melts into the mantle. Does that make sense? And that is why, my friends, that there are a lot of volcanoes on one side of the subducting plate. And not only that, but there's a lot of earthquakes that are on one side of the subducting plate, and we're looking at that right here. If I show you the volcanoes, bada bing, look at all of those volcanoes. I don't know why I just turned like Italian. Bada bing, hey, hey, forget about it. All right, so we got all these volcanoes, which pretty much created Indonesia. Is these two plates are coming together. Doesn't what freak me out. All right. Now, there's a lot of stuff happening in this Western Pacific place, and all I can say about it really is this area is complicated. There's a lot of these small plates, like Mariana Plate, that kind of mess with you when you're trying to look at this area. So, I mean, I can't necessarily tell you, like, oh, this is exactly what's happening and all that kind of stuff. I'm not a full-on geologist and whatnot, but it's complicated. That's what it is. We cool? And yes, I think I am recording this. Hopefully I am. So, I'm going to take a look at a couple more places. Hey, let's take a look at the ocean floor in this area and see what happens. See, I guess what makes it complicated is, why is it, what's kind of going on here? It's almost like this thing is spreading. We got a spreading site right here. We got some spreading out over here, some spreading out over here. We got some earthquakes coming in over here. We've got a subduction zone coming in over here, and more spreading over here. It's kind of crazy. What is the purple? The purple is 300 to 500 kilometer deep earthquakes. Cool? All right. I'm going to take you over to one of my favorite places, California. Yay! In fact, do you guys know where this place is? San Francisco's. The home of the Eagles, not the home of the Eagles. This right here is the Golden Gate Bridge. In fact, this is where I went to college. Let's see. Okay, bring me to Berkeley. So there's the California. Those are Golden Gate Bridge. I went to college right over here. In fact, this is where I studied physics. This is a giant clock tower that's in Berkeley. It's a beautiful campus, really. And here is where I studied physics. This is called LeConte Hall. Whoa. That's interesting. It's a very ugly map. But it's really cool. I mean, they mapped the actual territory onto that. That's pretty awesome. Alright, anyway, hey, let's go up the street and we'll go over to Memorial Stadium, which is really cool. Alright, so I played in the marching band at Cal, and we would practice over here on this field right here. But the band room was right here. The band room was right over here, right there. No, where was it? It was right around here. This is the band room, and then what we would do is we would march up the street over here, all the way over here, march over here, and play at the Memorial Stadium. This is where the California football team would practice. In fact, is that actual players on the field? No way. Even better, it's the band. It's because I'm a nerd. Alright, anyway. Check this out. Here's the problem with alright, let me zoom out a little bit more. Here's the problem with Memorial Stadium. Memorial Stadium is a beautiful stadium, and now you guys are like, why is he talking about all of this stuff? I'm going to show you guys. Here's the problem with it. Okay, wait, I need to. There's Berkeley right there. I'm going to show you a plate boundary. Actually, the plate boundary actually comes up this way right here, and it's called the San Andreas Fault. It's kind of a big problem. And the reason why it's a big problem is because what it causes a lot in California is earthquakes. Let's take a look at the earthquakes. Earthquakes is seismology. There we go. Now, look at where the boundary is, okay? And look at where the earthquakes are. In fact, if we go down towards where, who's from there? Was it Sophia? You were saying you were from California? No. Who's from there? Sarah. Oh, Sarah, yeah, that's right. You just came from California. So if we're down in California, we're down in like San Diego, California, which one of my good friends lives there. You got a lot of earthquakes happening on one side of the fault line, and you got a lot of earthquakes happening on the other side of the fault line. You guys see that? There's earthquakes kind of on either side. So we don't have earthquakes all in the middle, like right exactly on top of the fault line, which or on top of the plate line, which would signify a diverging plate. We don't have earthquakes all over the plate, I mean, all inside, just on one side, like we see on converging plates. We have them kind of all over the place, which is a good indicator of we're looking at a transforming earthquake or transforming plates. Now, the thing about transforming plates is the earthquakes aren't really even as big. You know, in the subduction zone plates, you know, like these guys right here, those are bigger earthquakes than these ones. However, these earthquakes happen in very populated areas. So you're going to have a problem when you have, you know, that kind of stuff going on, because there could be a lot of death and all that kind of stuff. And if we look at the seafloor age, that one doesn't really tell us a whole lot about when we're talking about transforming plates. Okay? Alright. I know that some of you have to leave. I have one more place I'd like to show you, and then I'm done with the lecture. I'm going to stop this thing, and then I will answer questions. Sound good? Alright. And whoever has to leave, you can leave now. That's fine by me. Alright, we're going to take a look at one more place. We're going over to get some Greek food in the Mediterranean Sea and all that kind of stuff. I'm going to look at the seafloor age. Oh, that doesn't help me out much. I'm going to look at the earthquakes. They're all over the place. I'm going to look at the volcanoes. They're kind of in these little arcs right here. But anyway, my answer is the Mediterranean Sea, also complicated. Why? Because it has a lot of small little plates. In fact, to be honest with you, if you want to look at a more detailed map, not the Google Earth one, but the one I actually kind of gave you, that one, let's see, let's look at that. Okay, wait, where is the map that I want to show you? I'm going to look at, and these are the topography. Here's the earthquake map. There we go. There we go. Take a look at that. This is the earthquake data for the Mediterranean Sea. She's complicated. Yeah, it's complicated. So I'm not really going to go into exactly how those plates are moving and whatnot, unless you folks want to take a geology class from me. And actually, you wouldn't want to take a geology class from me because I actually did a major in geology. I don't know too much about it, but I do know about this. I know about rocks, which is what we're going to cover next week. So, folks, we are done with our WebEx. I will show you what to do with the maps. All right. Does anyone have any questions, concerns, comments, vomits, etc.? If not, I'm going to stop the archives, and then I will answer questions. And I'm done at 12:25, and I finished on time, and I didn't have to say to be continued.